Hello, this is Chapter 8, video number 2. Today we are going to be combining two separate things that we already know how to do. First off, what we did in video number 1 was the sampling distributions of a sample mean. We learned how our sample size does affect that distribution. The more samples we take, the smaller that standard deviation, the more condensed that normal distribution is going to be. And we're also going to connect that to Chapter 7. Chapter 7 was our normal distribution where we started to calculate different probabilities. So here is the problem that we have today. First off, the heights of U.S. women follow a normal distribution with a mean of 64.5 inches and a standard deviation of 2.5 inches. So using that piece of information, this is our average female height in the U.S., and then this is our standard deviation. Now, here's what it is asking for us to calculate. First off, it wants to know what is the probability that just one randomly selected woman is 67 inches or taller. So just one random person, if we sample them, what's the probability that they are 67 inches or taller? And then finally, the second one, what is the probability that 10 randomly selected women have a mean height of 67 inches or taller? So two separate questions. First off, this is just one person. Our sample size is 1. Second one, that is we are taking a sample of 10, so that is going to change our standard deviation. All right, so let's go ahead and do the first problem first. First off, with this distribution, I am centered at 64.5 inches. That is what I am expecting. And then finally, my standard deviation is going to be 2.5 inches. Now, technically, if you wanted to, you could divide by the square root of our sample size. But let's think about that. If I divide it by the square root of our sample size, well, our sample size here is just we're selecting one person. So what am I going to do? Divide by 1? It's not needed for this problem. So with a sample size of 1, you do not need to divide by the square root of your sample size. Now, I want to know what is the probability that a randomly selected woman is 67 inches or taller. So 67 inches here, that's actually perfectly on this, 67 inches. All right, and I need to know what is the area to this side. Now, we could guesstimate this by the empirical rule, but I do want to go ahead and be a little bit more accurate on this one. So we have a mean of 64.5, standard deviation is 2.5, and I want to know the probability that we are at 67 inches or taller. This sounds like a problem for technology. So I'm going to go ahead and pull up Desmos. And remember, this is a normal distribution. Our command will be normal distribution, normal dist. Our mean was 64.5. Our standard deviation is 2.5 inches. All right, and I'm looking for that cumulative probability. I want to know what is the area under that curve. So for my two endpoints, I'm looking at 67 inches up towards infinity. So if I do this, 67 inches all the way towards infinity, and our probability there is 0.159, 0.159. That is our probability, 0.159. So if I were to gather 100 women, I'm expecting, right around 16 of them to be 67 inches or taller. That is the probability that one person is 67 inches or taller. All right, and this next problem, very little changes between these two problems. So first off, now I want to select 10 randomly selected women, and I want to know what is the probability that they have a mean height of 67 inches or taller. So we are centered at the exact same thing. I have 64.5 inches. I'm still centered there. However, one thing is going to change. I am not selecting one woman, I am selecting 10. So our sample standard deviation is going to change. So I was expecting a standard deviation of 2.5, but I need to adjust for my sample size. We are dividing by the square root of our sample size, square root. We are selecting 10 women. So We have 2.5 divided by the square root of 10. So I'll go ahead and calculate that out. 2.5 divided by the square root of 10. My new standard deviation is much smaller. Instead of a standard deviation of 2.5, my standard deviation is only 0.79. 0.79 here. 0.79. All right. And the rest of this problem, actually, I still have everything in Desmos. I'm going to go ahead and draw it out anyway, though. I'm still looking for what is the probability that these women have an average height of 67 inches or taller. All right, so that is my endpoint. I'm looking off towards infinity. So let's go ahead and go back to our Desmos. I already have this in. My mean was 64.5. However, my standard deviation has changed. My new standard deviation is 0.791-ish. Now, we are looking at an endpoint of 67. That did not change. We're going off towards infinity. And this is a very low probability to have 10 women that have an average height of 5'7". That is 0.00079. 0.00079. 0.00079. All right, and let's just think about this logically, why this would be. Most of our women are going to be centered around 64.5. It's possible that some women are 67 inches. Some of them might be 70. Shoot, you could have 72 or 74. You could also have the other direction. But the more and more women you bring to the sample, the harder it's going to be to get away from that 64.5. So your homework for today will be on the My Math Lab. It is chapter 8, video number 2 homework. I believe it's just 5 short questions. And it's asking you to do the exact same thing we did here. Some questions might be asking about one person being selected. Other questions might be asking about multiple people selected. So make sure you adjust your standard deviation appropriately. Have a great day. As always, let me know if you have any questions. Thank you.